all that effort, can someone remind me what the final graph, I think the minimum was it out 1, down 4, something like that? Where was it? Out, out 3, down 4. Okay. Let's put that on there. And I'm hearing 2, 3, 4. Let's make it real quickly. And we have this. And can someone remind me where were the x-intercepts?
1 and 5.
1 and 5. I'll get that out of the way. 4, 5. Y-intercept was 5. Here. And yes, we had a graph that looks something like this. I think. Is that true, guys? Now, I heard Alexandra say, Professor, in the textbook, they call it, or they name something vertex. Yes, on a parabola, the turning point, this point, is given the name vertex. The turning point on a parabola. It just so happens that vertex is also for us a what? Minimum? Don't use that word. Now, the discussion with the student here, which I'm glad he asked, there's a minimum. Could that point be identified as a local minimum and an absolute minimum? Is it both? Yeah, so if they ask for the minimum, they're looking for the absolute. So that can be identified as an absolute minimum. It's also a local minimum. Guys, it looks like this, and I had a few questions, domain, range, all that business. We had got that out of the way. But it looks like that. So, Professor, what are you going to do with this? Well, on the side here, someone remind me, was it x subtract 3 squared? And down 4. Did it look like this originally? Yeah. And we've already discovered by graphing that the minimum is -4, wasn't it? And it's so, I mean, you can't visualize unless you think, Professor, no matter what I replace x by, and you said if I have 30 students, and those 30 students replace x by a different x value, that you cannot get an answer coming out lower than -4. You can't. The graph shows you cannot get an answer less than -4. If you do, something's wrong. You did the arithmetic wrong. Now tell me, that function, now suppose I ask my same 30 students, now say, go through guys, and replace x by, in this function, an x value of your choice, and all 30 different x values, not the same x. Crunch it out, square it, subtract 6 times it, add 5, and get a final result, and tell me what you get. Can anyone tell me where am I going? Where am I going? If I say now take this new function, x squared subtract 6x plus 5, and do the same thing with it, replace x by any number of your choice, crunch it out, tell me what you get. Can anyone tell me what might I be doing here? Where am I going? I think after that break, your little creativity left you. Maybe we should start taking the 10-minute break at the end. Yeah. What do you think, guys? Does anyone think they know the relationship here? This function right here is going to have a minimum of -4 again. I don't care what you replace x by. In x squared subtract 6x plus 5, you're going to get, I don't care what you put in here for x, you put square root 2 in. Crunch it out. 10 in, crunch it out. -10, 3.5, 4 2/3. Crunch it out. No answer is going to come out less than -4. How do I know that? Are these two functions the same? Are these two the same?
Yes.
In fact, if you expand this out right here from across the street, that's x squared subtract 6x plus 9 right there. I see the x squared subtract 6x and got 9. 9 subtract 4, 5. Are we talking about the same function? Now you slow down a little bit. I don't know whether you're still on break in your mind or what. But you slow down a little bit. No one gave me an instant or a quick answer like, Professor, it's -4. It's -4 again. Now, if I cover this up, now if I ask you where is the minimum or what is the minimum value, if it's in this form, I'll think you'll say, well, Professor, you graphed it for me. And the vertex is what? Out 3, down 4, wasn't it? Well, here's the vertex. Out 3, down 4. Please tell me, if I leave it in this form, is it easier to see that -4 is the minimum value? Not as easily seen here. Even though it is. Even though it is. You're okay. What was that, parabola?
No, it was just a wireless collar.
Yeah. Jeez. I go to the club also. I think I heard that. At the club, last time I was in the club. I heard that. Okay, now. Guys, lesson here is, can I, with your help, if it's not in the form I'd like to have it in, I'd like to have it in this form. Can I change this into this? That's the whole thing about the next part of the class is, can I take a function that's given to me and rewrite it in, and they call this the vertex form. Of a quadratic, because you can easily look at it and tell there's a horizontal shift 3 to the left and a vertical shift down 4, which tells me immediately 3 to the left, 3 to the right. 3 to the right, down 4, it's going to be written like this. Out 3, down 4. Yes or no? If it's written like that. If it's written like this, and I've seen somewhere myself, I go, oh, hold on. You're asking me what is the minimum value of x squared subtract 6x plus 5, Professor? It's not as easily identified as if it would look like this. So I need to change this into this. And to do it, this is where we do this. Now watch carefully. Had a nice class tonight. Now, you got to remember, I asked you to do a completion of the square on the first exam. So you know the process. The leading coefficient must be a 1. We lucked out. Is the leading coefficient a 1 right now? So I need to, in step 1, start the completion of the square. Guys, to remind you what we did, we isolated the x terms. So I'm going to move that 5 over. By the way, the f of x is the same as y. It looks better as a y here. So let's move the 5 over to the other side and have the x terms isolated. Then what I did, some approaches are a little different, I asked you guys to come up with a number, I placed a blank, on each side that would complete the square. Same process I did, you did on the first exam. And if you don't see what that number is, you will know what it is. You take half this or divide this middle coefficient by 2 and do what? Square it. You end up with a 9. Both sides. Completion of the square. Therefore, that right-hand side will look like this, which we wanted. It's a nice square. We did this earlier. The other side, put my numbers together, right there is y plus 4 is equal to that. And finally, you get the y completely by itself, solve for y, move the 4 over. Now, have I changed this and made it look like this? That's a completion of the square. And then I could answer tons of questions now since it's in this vertex form. I could visualize real quickly the parabola, everything else. I could do it quickly now if it's in this form. By the way, guys, here's our horizontal shift 3 to the right, the way it looks, and a vertical shift down 4. So there's a horizontal shift to the right and a vertical shift down, and and by the way, those shifts tells me where the vertex is going to be located. Go out 3 to the right, down 4. Is that where my vertex is going to be located? And that is what this was here also, I think. And then you can answer tons of questions. With me? Now, I wish, I have one coming up where it's a little bit tougher. I wish they were all as easily done with completion of the square as this one. They're not all as easily done. But that's the process. But you know how completion of the square is. If you make one little mistake, you put the wrong number here, this is what happened on that first exam, that's going to throw everything off. You will not be able to graph it or even answer the question for me. I saw a hand going up, I think, before I jump into a more challenging one. Alexandra.
Why does the 3 become positive?
Okay, let me hang on a second here. Beautiful. Why does that 3 become positive, guys? Tell me, I'm glad she asked. Tell me, with all that we've done today, why might I assume that that 3 is, when I name the vertex, it's a positive 3. We all can see a definite negative 4. Beautiful question. Why, Professor, is it 3 there and not negative 3? Someone give me a good rationale. See a hand going up, yes.
It's a shift right 3.
It's a shift to the right 3. Is it? If it had been this, which it wasn't, it was a horizontal shift to the right 3. If it had been this, which it was not, then that would be what? Negative 3. That would be a 3 to the left, which it was not in my case.
It's 3 minus 3 is 0.
Also 3 minus 3 is 0, and 0 is usually on the parent graph. That's where the parent graph starts. You replace x by 3, you write back to 0, 0, which is where the parent graph would be. That's another way to think of it. Guys with me? Now, part 2. Here we go. What a lesson today. You have one of these on the exam. So I gotta find something here nice. Oh, here's one nice. F of x is equal to this. Oh, you know what? Let's make it a negative. Negative 2x squared. Now, I changed my signs at the last moment just because I want something a little bit more challenging. Let's hope it works. Okay, it looks like that. I like to sketch it. I like to sketch it. We're going to get into some shortcuts here. Guys, should it graph into a parabola?
Yes.
Now, parabolas can do one of two things, open up or open down. What should this one be doing? Down, because I see that leading coefficient's negative, that's why I changed it to a negative. So when I get my graph, it better be doing that. True? When I do it. By the way, if it does, this one has a what? A maximum value, not a minimum value. If it opens down, so there's a maximum value here that the function takes on. There. Now, I know I've got a clever class, and I've got some students who are really clever. I've seen their work already. I'm going to sort it out there. We're nowhere near what I want to do yet. Does anyone think? Back here, the minimum value was -4. They just want the y. Does anyone have an idea what the maximum value might be on this graph? I doubt it. Does anyone have an idea?
-2.
I heard what now? 2? Think it goes up to 2? Okay, 2 I heard. Anything else? What do you think the highest that graph goes up to, which is absolute max, or just the maximum value? I can't tell myself right now. Now, let me place it in, I got rewrite this. I like to place this in vertex form, which may help. So I'm going to rewrite my function in vertex form. Guys, step 1, completion of the square. Please, let's write this as y, much easier to work with. I'm going to divide everything by a -2 first. The leading coefficient must be a 1. There it goes. Y over a -2, x squared plus 3/2 x minus 1. Let me step back and look at division by -2. Looks good. That true? Is my leading coefficient a 1? Which says now I can continue. I've got to be careful though. Now when I say continue, that means let's isolate the x terms, move the 1 over, place that blank, and then I have the terms that contain the x, place the blank. Okay, watch carefully, you have one of these on the test. Can anyone tell me what is required on that blank to complete the square? Well, if you can't see it, we did this in class way back. Take 1/2 of that coefficient, 1/2 of 3/2, you guys agree? Which is, let me use a different mark here, this is better. That's 3/4, much better. And then do what with it? Square. And that will tell me my number I need to add to each side. Now please, I'm not trying to be mean. I'm not a mean person. I'm not trying to be mean. But if you place the wrong number on that blank, I can't do much for you in scoring. Your graph's going to be really thrown off. The key there is that number. Now, if that's the correct number in this case, let's get the right-hand side out of the way, guys. Please tell me, what is that nice perfect square that I'm looking for on the right-hand side?
X minus 3/4.
X, thank you, x plus 3/4. That's what I wanted. The other side, I've got to clean it up. We'll put my numbers together. I'm gonna write y over -2, I'm gonna leave that alone. I'll put my numbers together with the common denominator of 16, these two right here. Please tell me, save me a little time here, is it 25 over 16?
Yes.
Those two put together. Common denominator 16. I gotta solve for y. I gotta get the y by itself, as we should for vertex form. So let's go down to step 3. And to get the y, guys, we move that 25 over 16 over, out of the way. That's been moved over. And now to finish it up and get the y completely by itself, what's my last step? Multiply by what? -2. Both sides. The negatives will cancel on the left, which I want. That's the y. That's what I want. The other side, a -2, of course, with the parenthesis next to it. You can square it. And be very careful, when I multiply the n term by -2, which I must do, I will end up with a positive what? 25 over, help me out, 8, yes or no? You got quiet.
Yeah.
We may need that club music again. Okay, 216, 8, 25 over 8, is it 25 over 8?
Yes.
Let's cancel 216. Now, can someone tell me, where is my vertex, the turning point of this upside down parabola, it's opening down, located based on this, and before you answer, if I were a student and the instructor says, this is the same as this, I'd say, no way. They look so different. No way. Why, Professor Ramsey, why would you change this one that looks nice? Look at all those nice little numbers up there. Why would you change that in wetness? Because now I can tell where the vertex is. Now, can anyone look at this and tell me in terms of shifts? If I were to graph this, what are the shifts that will lead me to the vertex? A horizontal shift would be 3/4 to the left. Is that true?
Yes.
Right like this. And this indicates what? There's a vertical shift, what? Up 25 over 8. 3 1/8. There's my vertex. Did I name it correctly, guys? Did I name the vertex correctly? There's a horizontal shift here to the left, or I heard one student say replace x by -3/4, professor. -3/4 plus 3/4 makes this a 0. That's another way to get that. And of course, this one's obvious. If the number on the end is 25/8, it's got to be the vertical shift, isn't it? Up. Hang on just a second. Oh boy. Do we accept that? Now, you said, Professor, are you going to go through all that detail like you did before the break, where you went through transformations, you graphed all this? No. I changed my mind. Before I graph it, suppose the question was just this. If all 30 of my students went to this function here, I erased a little bit, -2x squared subtract 3x plus 2, and my TA up front, she puts a number in of her choice, next student puts in a different number, and I have 30 different numbers, x being replaced by 30 different numbers, and it comes out an answer, comes out an answer, comes out an answer, after you crunch it out. Can anyone tell me at this point something about that answer coming out? Or maybe I should phrase it like this. Suppose I collect the 30 answers. Keep in mind, students are putting a different x value in. So there's 30 different x values being put in. And they crunch it out for me. -2 times that number squared. This business, crunch it out and get an answer. I collect them real quickly. And I see an answer of, hang on now, I see an answer of 4. Someone give me an answer of 4. Now, can someone tell me right quickly, how do I know? And I'll go right to that student and look at him and say, you're wrong. That's why you do my numbers so quickly. How you know that I'm wrong? There's something up here that tells me if you got an answer of 4, I don't know what X you put in, you can't get 4 to come out. You cannot get a 4 to come out. Can someone tell me why?
This 4 is more than 5.
This right here is out -3/4 up 3 1/8. I think 25/8 is 3 1/8. And that, since it opens down, is that right there? Is that the vertex? Right there's your vertex. It goes up to, for a max, 3 1/8. How on earth could you get a 4? You can't. That's the max. I can see it right now. That's the vertex, right here. -3/4, 25/8. This is what I'm focusing on. By the way, is that going to be an absolute max when I finally get it? I hope so. Okay. Guys, I'm looking at my time. I know me. Yes. We're going to graph this one. We're going to graph it completely. Okay. Now, you said, Professor, are you going to do it through transformations? Oh my goodness. Professor, we'll be here all night. If you say do it through transformations, now hold on, we may just go to the final graph. You have to take the parent graph and reflect it through the x-axis. What does that 2 mean with it that you'd have to do? If you're going to do it through transformations, the 2 out front means to do what? A vertical stretch by a factor of 2. And to get that effect, you have to find some y coordinates and multiply them by 2. Vertical stretch. This says there's a horizontal shift to the left, 3/4. You got to do that to the graph. And this says there's a vertical shift up 3 1/8. Got fractions to worry about. You have to do that to the graph. You have to do all those transformations. I've shown you one where it's so lengthy that you can get lost in it. So let's just show the final graph, final resulting graph, if you should have done all those transformations. Guys, to do it, in other words, I like to graph this. By the way, right now to me, even as an instructor, there's no way I could quickly look at these and say, oh, those are the same. Are you kidding? They are the same. Just so I can find that vertex. Now, or in this case, the maximum value. I'm gonna sketch it, watch carefully. But time is beautiful here. Okay, guys, let's sketch this. I'm not going through all the transformations. Not on this one. We'll just go to the graph. Save you a little time here. Here we go. Jeez. I will do this though, since I'm not going to go through all the transformations. I know and you know if I plot this point, negative 3/4 up 3 1/8. I get that out of the way. Negative 1, 1, 2, 3, 4. Let me go ahead and plot that point. Let me use a different color here. Negative 3/4 up 3 1/8, because it says right in there. I'm going to label this as my vertex. There's my vertex. What else do you think I'll ask you to find to finally get the graph? And I'm not going to do the transformations. What else do you think might be nice to know to get this upside down graph opening down?
Intercept.
The intercepts. So we'll find the x-intercepts. And I'll have all this written on the test if that's what I'm looking for. I should find this. Let's hope they're nice numbers. Find the x-intercept, go back and replace y by 0. Now guys, we'll do it in the original myself. This is the original function. And I set that equal to 0. Believe it or not, I've got some students in this class. Some students have asked me in the past, Professor, could I have gone down here and set the y equal to 0 on this form? You could. And you get the same x-intercepts. But many students are frightened with those fractions. So that's why I went back to the original. Guys, to solve this, let me get rid of that negative. Multiply both sides by a negative, which we should do. I hope this factors, for goodness sakes, I'm not in the mood for quadratic formula. 2x, x, plus 2 minus 1, and step to the side. Thank goodness it does factor. Split this up. You're going to end up with x is equal to, what is this, 1/2? And x is equal to a negative 2. Let me write these as ordered pairs, and I think they look better. Those are my x-intercepts. You get partial credit for all this, even before you get to the graph. The y-intercept. That's easy to find, I think. And that is merely go back and replace all those x's by 0. In other words, find f of 0. Now, to save you a little time, you know if you go back and replace all these x's by 0, the first term's going to cancel out. Second term's gone. I'm left with a 2. I'll write it like this. Looks better. Now, you have enough to sketch the graph for a rough sketch. Right, guys? Okay. Now, I got the vertex there. Let's put the x-intercepts. Let me mark this as 1 here, guys. I work with it. So 1/2, I'll place right here. Go ahead and label that so I can see it. Negative 2, let's go out here. That's another x-intercept. Y-intercept up 2. Now, is that enough to connect and get that upside down parabola? Yes or no? Did I plot all the points correctly? So does it look something like this, maybe? Up here, comes down, and does that. Is that reasonable? Is that the graph? Without going through all the transformations. X-intercepts, Y-intercepts, and that. There's my vertex. By the way, is that the highest point on the graph? So is that a maximum? Yeah, the maximum value we said earlier was, in this case, 25/8. Same thing here. The graph shows it. Nice. Next vertex, maximum value. No problem. Now, are there other things I could ask? I'll ask you something simple here because I gotta move on. Domain, I think the domain is easily seen as all real numbers. Range, the up and down, be careful. How would you describe the up and down on this parabola? Is it negative infinity? Up to, what, 25 over 8, inclusive. Yes or no? How could you go wrong? 25 over 8. Is that true? About domain range? I know I could ask you when's it above the x-axis, when's it below. I could ask you other questions, but I gotta move on. That's done. Now, hang on. I've been waiting for this all night. Mr. Kahn, you with me? With me?
Yeah.
Okay. Been waiting for this all night. Here's the professor. I see, if you ask me to do completion of the square, professor, I've got to prepare for this test. Because I had 15 A's on the quiz. Please tell me I get 15 A's on this exam, 80-point exam. You know you're going to do something like this. Try to make as much sense of this as we can tonight. Now though, on the side here goes. I'll give you a function. Just like that. I see some students with a look on their face like, as soon as you see fractions. Now, I say, professor, for goodness sakes, you're not going to do what you do on this one, you did on the last one. Are you going to complete the square on this, professor? I'm supposed to. It would work. I realize I got a negative 1/4, which looks scary. And I know I got to make this leading coefficient a 1. Can anyone tell me, if I were to do it like I did this one, what would I have to do to begin with to make sure that leading coefficient is a 1? I multiply everything by, or do I multiply everything by what, -4?
Yeah.
Multiply both sides, but you gotta do it on both sides, -4. Now, guys, we're not gonna do it completely here. I'll show you why. You said, professor, I know that much. It would now look like this. Everything multiplied by -4. Help me out here. That's plus, and negative times negative, plus 6 over 4. No, I'm multiplying everything by 4, aren't I? Is that 24?
Yeah.
Jeez. Is that 32? You kidding? Is that true? Is my leading coefficient a 1, which I wanted? Is that true?
Is it minus 32?
Or is it -4? Yeah, -4. Multiplying everything by -4. That is negative. There. Now we step back and look at it, looking good now. Ah, darn. Let's go ahead and put it in vertex form. This is not going to be that bad. Move the 32 over. Add a blank. Add the blank. Now I created this one just standing here, so I see there's going to be some awkward numbers. Can anyone tell me what would it take on that blank to make this work? Half of this number here is squared. That's what, 12 squared? Is that 144? That's what I get for making problems that I stand here. But the right-hand side would be x plus 12 squared. For sure, I want that. The other side at this point is -4y. This red marker's gone out on me. A -4y. Guys, 32 plus 144 is 176? Okay, jeez. And then you gotta get the y by itself, solve for y, move that 176 over. It's got awkward numbers. And you're gonna have this, move that 176 over. Oh my goodness. Don't let me make a mistake now. And then do what to finish up? Divide everything by -4. Everything. These will cancel, get y is equal to, best expressed as out front you have actually this. On that first term. Now if I divide here by -4 here, this turns into a positive, doesn't it? Does 4 go into 176 evenly? Is it 44?
Yeah.
Positive. Are you kidding? Jeez, just big numbers. I hope we don't have a mistake in the math here, do we? We're okay? Now, I'm not gonna graph this one. I'm not gonna graph it. It opens down. I know it opens down. Can anyone tell me just by mere observation, where is my turning point called the vertex located, just by looking here? -12, 12 to the left, horizontal shift, and vertical shift, what, up 44? There's your vertex. And therefore, that vertex, like over here, is acting as a max, since it opens down. Therefore, the maximum value this function can take on is 44. That's the max it can take is 44. Now, please tell me. You know you're gonna have one of these. Here goes. Good way to close down class. Would it be helpful if there's another way to find this without going through this? To find that without going through all this. Wouldn't it be nice if you had another way to find right quickly, within seconds, where that maximum or minimum value is located, unless you're required to show completion squared. But suppose on one part of the test it says just find the max, find the min. And I don't mention completion of the square. Would it be nice for another way that you could find this, for example, on this last one? In fact, on this first one here. I've erased the function here. I'd like to find this 25/8 within seconds. Without going through all the work I just did to get 25/8. Or on that last one. Okay guys, here it goes. Bear with me. Get ready. This is a good way to close out class. If you're ever becoming alert, be alert now. You got the music for us? We're gonna be alert here. Okay. Here we go. Oh, I've been waiting for this. Here's your function. Without numbers, I'm going to give you a standard form. All quadratics look like that. ax squared plus bx plus c. Now, don't get lost. Wait till you see what happens. I want to complete the square on this. No numbers. I'd like to complete the square on this. Oh, are you going to be shocked when we do this? It's going to get messy, but wait till you see what happens. Anyone tell me what would I have to do on this if I want to complete the square on it? Thank you. The leading coefficient must be a 1. So divide everything by an A. This is UCLA now. We call this Y. Let's hope one of these black markers will work here. Let's call this Y equals this. ax squared plus bx plus c. Step 1, I heard my students say, Professor, you got to do this. It's gonna look awkward. Y over A. Now if I divide by an A, the A's cancel in the first term, gives me an X squared. Second term looks like this. Third term looks like this. That's division by A. By the way, is my leading coefficient at this point 1? Gotta have it. Now I can start the work. Now since the leading coefficient is 1, I need now to do as I have done earlier with numbers. I need to move that C over A over, out of the way, and get ready to determine what is required on that blank. Just like we did earlier, but we had numbers. Now, how does one determine what's required there? You take half of the coefficient in the middle, half of this coefficient, so 1/2 of B over A, which I think in this awkward problem is merely B over 2A. Is it true? Then do what with it before I add it? Square it. Same process I've been doing all night. So take this, square it, which is B squared over 4A squared. That goes here and here. Same as I did with numbers. Now, if that's true, here we go, guys. I'm gonna call this step 3. If that's true, step 3, the right-hand side should be a nice, perfect square. Can anyone tell me, in this accelerated class, what is that in factored form? I see a hand going up already. Hang on just 1 second. I'd like to see more than one hand go up. Does anyone think they know what the right-hand side, because we did completion of the square. It should be a nice, perfect square. Does anyone have an idea? It may look awkward. Does anyone have an idea what it is?
Put X squared plus B over 2.
We'll do it again.
X squared,
Not X squared.
X, sorry, X plus B over 2. Almost right.
It's gotta be. Really? That's it? Is that it? It's factored. Now, the other side, based on what we've done tonight, I think I had some numbers tonight. I don't have numbers this time, but it's the same process. I gotta put these two together. In this case, with a common denominator. Because I gotta eventually get the y by itself, as you saw me do earlier tonight with numbers. Guys, this is a little awkward. My common denominator to put those two together is 4a squared. That means I have to multiply this one to make things work by 4a. Now, both of those have the same denominator. Now we put them together. So guys, on the left-hand side would be, here we go, y over a, still there. That I just blocked off, put together is negative 4ac plus b squared, all over a common denominator. Is that true? Yes. Now I'm gonna write like this, if you don't mind. I think it looks better written as the b squared first since it's positive. Minus 4ac, all over that common denominator. That's this put together with a common denominator. Welcome to calculus. Oh, pre-calculus. Now what? Step 4, Ignacio. Eventually I'm supposed to get y by itself. I've been doing that all night. So I think I need to move this mess over. Is that true, guys? Now, I'm going to have y over a all by itself on the left. I'm going to eventually get a by itself. And I'm moving that strange expression to the right. And I'm going to be clever. If I move it over, will these two change signs? These two terms. Will they change signs as I move over to the other side? Does this become a positive 4ac minus b squared? Still over that denominator. So let's write as 4ac that's 4ac minus b squared all over my common denominator. That's what it looks like when I move this mess over. All that mess moved over. Looks like that. What's my last step, finally, to get the y by itself? Multiply everything by a. You guys, here goes, out there. Watch what I'm doing here. This is x plus, rewrite what we have. And down here, of course, we have this. And Billy just told me, he said, Professor, if you want that y by itself, which I do, you gotta multiply everything by a. Every term by a. Left-hand side, the a's cancel. That's why she said multiply by an a. That gives me what I want, the y. Right-hand side, first term, an a out front of this. Now, can anyone tell me what on earth will I get on the end if I'll have to multiply it also by a? From algebra, will one of these a's cancel out and give you some a? So on the end, will I end up with, may look a little strange, 4ac minus b squared all over what? 4a. Yes or no? Ooh. I didn't make a mistake, did I? Please do I did. Now, looks strange. I did all my numbers tonight. Now, can someone cleverly tell me where is the vertex of this located? Name is the coordinates of the vertex. Go for it.
Negative b over 2.
Now, why did you say negative?
Because whatever's in the primary function or the parent function always balances out.
Always goes back to zero, bounces out to zero, replace x by negative b over 2a to cancel out to a zero. Or other students may say, Professor, that means there's a horizontal shift to the left, b over 2a. That's another way to think of it. And my y coordinate, oh my goodness, it's this. Is it? That's what we've been doing tonight with numbers? Now it looks strange, I mean really strange. You say, Professor, what is that? What is that? It's a formula. It's a formula that you can now turn to and find where the maximum or the minimum value is. No graph required, no completion of the square required, just this formula. If you know how to use the formula. Now, I'm looking at my time here. I got 5 minutes. I'm going back to this problem. I would like to, for this function, here's my example, here's my function, was negative 1/4 x squared, subtract 6x, plus 8. I would like to find the vertex, which we did over here earlier, without going through this business. Not completion of the square. What am I going to do, Billy? I'm going to go directly to this formula. And the formula says, if you want the x-coordinate, Professor, which I hope comes out to be when I do it, negative 12, use this formula here. So the x should be negative b over 2a. Okay, guys? Back here, they're talking about this a, this b. In my case, I guess it's negative b, in this case is what? Negative 6? Gotta be careful. Over 2 times a, 2 times a negative 1/4. Yes or no? Did I put those in correctly? Is that negative b over 2a? Or replace the b and the a? All together, I see lots of negative signs floating around. Will all that give me a negative answer? I think. And that gives me 6 over, here I can cancel 2 and 4, that's a 1/2. Like the 1/2 on the denominator. Yes or no? Please tell me, is that negative 12
Yes.
in arithmetic? Is that the same thing we got over here? Didn't touch completion of the square. Use the formula. I'll see them. If Ramsey's done it correctly, and I have, we got 44 here. That should give me 44. Let's see if it does. 4 times A in this case, what back here, negative 1/4. C on the end was 8. Subtract B squared, negative 6 squared. You can also make sure I have all this put in there correctly. Over 4 times A, 4 times a negative 1/4. Did I put all my numbers in correctly? These numbers into here, from here, yes or no? Now if I crunch it out, 4's will cancel. That's a negative 8 out front. Subtract, just this part's being squared, is that 36? Denominator, 4's cancel, negative 1. Is that a negative 44 over a negative 1? Please tell me, is that 44? Oh my goodness. You now have a formula. Now, the other question would be, does that represent a max or a min? And that all depends on you without a graph. Don't do a graph for me. It all depends on you recognizing this is a parabola opening what? Down, and so should this be down here a max that you're working with since it's opening down? If it's opening up, it'd be a min. 44 would act as a min or a max, and you're finished. In other words, please tell me, it took a little time here, is this formula much easier to use than completion of the square? I have 2 minutes. 2 minutes. Hang on, 2 minutes. I'll make your question. That's fine in less than 2 minutes for you now. Would this have a max or a min value the way it looks? It's a min, it's a parabola opening up. So the minimum on that graph. I like to find its value. You see how much time I have. I can't go through and put a blank on each side and all that business, can I? Of course not. I'm going directly to this. The x here should be negative b 4 over twice a. Do not let me make a mistake. Does it look like that for that part? Negative b over 2a. Or that's a negative 4 over 6, or probably a negative 2/3. Is it negative 2/3, guys? I think that's the x. That true? The big value I'm looking for, though, to answer the question, is the next part. 4ac, we got this out of the way. The next part is this, the y-coordinate. The y-coordinate is, oh my goodness, right like this, 4ac, a was 3, c is a negative 6, subtract b squared, subtract 4 squared, all over, if I have no mistake, 4 times 3. Let me step back and make sure I put all that in there. Guys, check and see if I did that quickly. I did quickly. Did we put everything in there correctly? Everything's in there correct? Now, arithmetic. This much right here is what? 12 times 6, what is it, 72? Negative 72. Subtract 16, that's 4 squared, over 12. Yes or no? And that's a negative what? 88, is it? Over 12. Now, a nice number. I can reduce it down, 88 over 12 by maybe 4. Make it look like this. Reduce it down by 4, negative 22 over what? 3? It's reduced down, is that true? Now, answer the question. What is the minimum value? You guys said this thing should have a minimum. What is that minimum value based on what you see up here with the help of the formula? Negative 22 thirds. It's the least value that function will take on. Yes or no? Isn't that cute? Oh, we explained it nicely. Guys, I'll be here at 4 o'clock on Wednesday. Would you guys like to see me at 4 o'clock on